In this video, we are going to see the third type of arc welding process, that is submerged arc welding process. So this is also comes under the type of arc welding. So you can able to see the architecture, that means the overall setup of a submerged arc welding. Here you will have a common plate and you will have a hopper where you will feed the flux material, and as same as your GMAW, the electrode is fed to the welding in the form of wire, right? And also we will give, since it is an arc welding, we have to form an arc, we will give the electrical potential, either it may be a AC current or a DC current. This is the common setup of a submerged arc welding. We shall see in detail about this process. What is submerged arc welding? So this submerged arc welding is a method in which the heat required to fuse the metal is generated by an arc. So since this is an arc welding, the common process of melting the material is by the type of an arc, so which is formed by an electrical current passing between the electrode and workpiece, right? So the process is same for all type of an arc welding process. We will give the electrical potential from electrode to workpiece, so that the electrical energy will be converting into the heat energy and it will melt the material and form a metal pool. So there is a no visible arc or any spark or spatter or fumes in this type of a submerged arc welding. So this electrode may be a solid or cold wire or a strip. So this submerged arc welding is normally a mechanized process. So there is no any manual process in SMAW, right? So this is completely automated process, right? So in this thing, you can able to see the complete electrical feed is submerged in the blanket of fused material, right? So in this, you could not see any arcing or sparking visibly, because it will underneath your blanket of a flux. So coming to the process, the submerged arc welding flux feeds through a hopper. So you will have a hopper here. Okay, in this hopper you will have a particulate flux. In the first type SMAW, you have seen the flux is coated over the electrode. In the second type GMAW, there is no any flux material. Instead of flux, we are using the shielding gas. In the submerged arc welding, that flux is used but not as a coated over the electrode. It is fed in a granular type, that means the powder type. You can able to see this is the flux. Okay, so the flux is fed into the welding through the hopper and continuously distributed itself over the short distance along the weld zone. So you can able to see this is the weld zone, means the flux is discharged throughout the weld zone. Okay, so the wire feed mechanism. So you are having a wire feed mechanism, right? So the wire feed mechanism brings to feed the welding into the joint at a controlled rate. So here the electrode is supplied in the form of a wire, and it is happen to be a controlled manner to have a proper welding rate. An electric arc is established, right? So you will have a one terminal which is connected to the workpiece and another terminal which is connected to the electrode. So it is coming together at a particular distance, that means 2 to 4 mm, right? So there is a formation of an arc because it is in a close proximity. There will be some electron flow. That electron flow will create some arcing process. So this carriage is started manually or automatically to travel along the seam. So this will be almost it is moved in an automated process. So coming to the parameter of a submerged arc welding. So weldings is shielded by a granule flux consisting of a lime, silica, manganese oxide, calcium fluoride, right? So we are putting the granules, no, this granules, right? So this granules is made up of lime, silica, manganese oxide, calcium fluoride, or sometimes calcium oxide also they are using, right? So these are the different flux material which was used in the submerged arc welding, right? So the flux insulates welding area, allow the deep thermal penetration, right? So we know that the use of flux is to protect the welding from the atmospheric air, so to avoid the oxidation. So also this flux is used to allow a deep thermal penetration over the welding area. So if you are having a deep thermal penetration, so it means that we will have a good welding beads, and also it prevents spatters and spark over the molten material. So that we can able to get a clean and tidy kind of a welding when we are going for the submerged arc welding. And definitely shielded gas is not necessary. Okay, so you don't have any shielding glass, so instead we are using the granular type of a flux material, and we are this will be operated in the ampere of 300 to 2000, and the speed, the movement speed. Okay, so the direction of a travel can be maintained 5 meter per minute, and thickness of a welding plate welding can be 4 to 10 types of SMAW, and almost a material like carbon alloys and stainless steels can be used. These are the some of the properties. And as you know, we are using the loose powder as a flux material. There will be some wastages. Okay, so the submerged arc welding can be classified into two types. One is the flux is not reusable, and another one is flux is reusable. In the reusable type of a flux, you can able to see we will have a tank. Okay, so this tank will take the unfused flux. Okay, so generally the portion at this welded portion only, the flux will be consumed by the welding process. This is unused unused flux. So that in the normal type, this will be considered as a wastage. When you are considering this type of an arrangement, the unused flux powder is there, no, that will be sucked to this welding, that means fluxed tank. So this is discharge of a flux, that means fresh flux will be put into the welding area, and this is the wire feed, that means nothing but an electrode, and this is the generator, and this is the workpiece. So it will the flux will be supplied here, and the welding happen beneath this flux. So it will wait. So the unfused flux can be sucked by this arrangement, and it will put into this tank, and it can be reused for any other purposes also. Coming to the advantage, using this submerged arc welding, we can get very high quality, little risk of undercut or any porosity, no spatter happens, high deposition rate, high thermal efficiency, no radiation is formed as your GMAW, high welding speeds are possible. Right? So you can able to see this submerged arc welding is a typical type of a welding where you can use this type of a welding for a very thick material, and also for a very high speed of welding things. But this is also have some disadvantages in terms of precise joint preparation cannot be used. Only we can able to weld the flat kind of materials. No observation of arc and process during welding is possible, so that we don't know whether the process is happening or not. Okay, because it is happening beneath the flex, so we don't see the arc, so that we are not clear whether the process is happening or not, and we are having a high operational effort. It cannot be used for plate less than 5 thickness. So the thin sheet cannot be used in this. Only thick sheets can be used in this process. Flux is subjected to contaminate because it is a powder kind of a thing. So definitely there will be some contamination. Also, it may absorb the moisture from the atmosphere. Okay, and solidification cracks can be happen. Irregular wire feeds also another set of a problem. Coming to the application, it is very good for fabrication of boiler pressure vessels and railroad tank cars, and structural shapes and cylinders, circular welds, beam production, shipbuilding, circumferential welding in wind towers, and longitudinal pipe welding. All the things can be welded using submerged arc welding. And very importantly, our rail tracks are there, no train tracks and all. So most of the train tracks are welded by this submerged arc welding only.